Yeah, hi, I'm Natalie. We're here to talk about threat modeling GitHub Actions, and specifically about how GitHub Actions is a little bit different than some of your incumbent CI and how you would have to change that threat model. This is not in the next 50 minutes going to be a 0 to fully in-depth threat model, just places that you really want to spend some extra time with GitHub Actions specifically. A little bit about me. I'm a squash merge evangelist at GitHub. If I could change my official title and workday to that, I would. And then I joined GitHub, but I led the real thing for years at Big Defense, doing all the alphabet soup of compliance stuff, kind of specific to developer lifecycle in GitHub specifically. So think NIST, CUI, CMMC, DFARS, ITAR, SOX, all the alphabet soup compliance standards. I was also involved in some of the 2021 Code Club exploit cleanup. So lots and lots of fun there. And slides, write-up, links, etc. will all be available on website here shortly. And I believe the recording is uploaded to YouTube later as well. So I tried to put all the links on the slide so you could do the take a picture. But if you miss something, please don't be alarmed. It'll come back around. And I want to just talk a little bit about why. So why you're going to threat model. You're really going to try to understand and consciously think through your systems, all of them, for security and stability as part of your software delivery. And normally when we talk about threat modeling, we're talking about the end product. So you build widgets, foo and bar, you're gonna do foo and bar. We're not talking about the threat model for foo and bar. I figure you've got this covered. We're talking about how you're building this. Because this is an increasingly important part of software craftsmanship. And your fast feedback and early feedback of your CI model is becoming more and more critical as you're trying to ship software faster and faster and faster. And nowadays, CI/CD is way more than your app's code. I started using a CI system called Hudson, is now known as Jenkins. Back when it was called Hudson. And at that point, it was pretty remarkable that you could have a nightly build. I think that's actually part of the Joel test. Is one of those things is, do you have a nightly build? And nowadays it is 2023, a nightly build, having to wait a whole day for feedback, that's pretty scary. But now we really need to start thinking through, okay, if we're getting feedback 10 times a day, what's the problem here? We have so much more code in our CI pipelines now. And this gets even more, I would say a little scary once we start thinking about GitOps and infrastructure as code, because it is a fabulous new way to learn how important repository permissions are. I learned that my very first experience with GitOps with a tool called SaltStack, still around, but not quite as popular as it once was. And I might have taken down a couple thousand users in production because we had Windows new line characters in a repo that got automatically pushed out to an Apache server and reloaded, and then all of Apache died, all of it, because of something that really probably should have been caught about 10 stages earlier. And it's also gotten OWASP's attention too. Now with the OWASP top 10, there's a new one now for CI/CD security risks. And we talk an awful lot about the software supply chain and about the dependencies that go into your software, and not so much about how that chain gets made. This is doubly important in the more regulated industries because we are starting to talk through what we call a maturity model. So you're always going to have threats. You're always going to make mistakes in your code. You are always going to have some sort of problem somewhere. Even if you don't today, there's nothing saying that you won't have a new vulnerability discovered tomorrow. So a maturity model is really, how do you deal with that? And consciously writing down your risks and what your process is a key part of that. So I have two things that we're going to keep coming back throughout this presentation. The first is these 4 questions. I told you earlier, you're not going to walk out of here with a comprehensive or complete threat model for your super special bespoke pipeline, but hopefully you'll have a really good starting point to build it. And I'll focus on highlighting things that I see folks overlook, my own struggles in having done this in a highly regulated environment, and honestly highlighting some of the easier wins. So the high impact, low effort spot of security, that's just, why are you not doing this? And I'll answer the first three. I will never answer that top four. As the great sage of love and life, Meatloaf, has said, he'd do anything for love, but he won't do that. And he never tells you what that is. I can't tell you if you've done a good enough job. Only you can. You're good enough for a web app that's handling some basic credit card processing. It's going to be different than the software controlling the nuclear codes. It's going to be different than the MRI handling your medical images. Like, what is good enough is really up to you. And the next thing we're going to talk about is the super duper simple pipeline. These can get very, very complicated very quickly, but I kind of wanted to tell you where in the SDLC that we are. So we're going to talk a little bit about what happens here, mostly in this build and deploy step. And here's a couple more things on that pipeline we're gonna gloss over, just for the sake of time. Do include these topics in your threat model. They are very, very important, but they're also kind of custom to you. So I'm gonna assume you know what Git and GitHub is, and some of the basics, things like managing a pull request, branching, forking, permissions, how to check for merging, et cetera. And if you don't, see me later. Happy to talk through the only appropriate merge, which is the squash merge. So next, endpoint management. So that whole far left side where the developer's laptop is, that is its own can of worms. Patch your stuff, but identity and access management is kind of its own thing. So we're going to assume that you have confidentiality, integrity, and access controls all kind of squared away. And then at the very, very right side of the pipeline, how your environment is set up. So like, don't, chmod 777 all the things. Don't put your passwords in an INI file for database, all the basic things. And most of this is not specific to GitHub. And what I mean by this is GitHub is super duper open about which parts of the platform you do and don't use. So if you don't want to use a particular part of the GitHub platform, like that's cool. Here's the API if you want to integrate something else with it. But we don't have time to choose your own adventure. So we're going to focus on GitHub Actions, GitHub's built-in secret store called GitHub Secrets, GitHub Environments, which is how you would segregate like development, testing, production, et cetera, and GitHub Packages. But it's the same general idea when you swap in other tools too. So you should be able to kind of copy, paste, and mix and match as much as you need to. But I do want to call out, like, very, very upfront, I have a bias, a lot of them actually. But let's call out some of the relevant ones first. I work at GitHub. I work with the super duper regulated crowd that I came from. Next is having been experienced in that super duper regulatory environment before I moved to GitHub. User friction is the leading cause of insecure things. And what I mean by that is nothing is quite as dangerous as a clever engineer working around said friction. So if you block access to GitHub, well, guess what? Someone's going to write a script on some EC2 or droplet or something to clone something from GitHub, move it to a shared location, and then it's going to come into your environment. Corollary to that is I have never, ever done anything. Not once have I disabled TLS verification to work around a corporate proxy. Nor have I ever run SSH over TCP 443 or abused web blob storage to do exactly what I said. So highlighting that is my bias of experience there. And then lastly is, technology is constantly trying to make me obsolete. And what I mean by that is when I got started in IT, I talked about Hudson. I also worked with Spam Assassin and Fail2Ban and Postfix and SendMail. And I don't really see those on like job listings anymore. Not too many people like know how to set up Postfix and SendMail and all that good stuff anymore. And I really believe that building and managing your own CI from scratch will go this way too. So here's where we're going. We're going to talk a little bit about what a GitHub action is. We're going to dive deep into what goes into a GitHub action. We're going to talk about secret management because that is kind of like my second big pet peeve is putting secrets in your pipeline, putting secrets in your code, putting secrets in places that they can be read persistently, all that jazz. We're going to talk about what happens when you do it yourself. Your threat model is going to change drastically based on whether you're using GitHub's hosted compute versus hosting your own compute. You can bring your own compute to GitHub Actions. We don't care. That's totally fine. We support it 10,000%. But it does change your model. And then we're going to talk a little bit about governing the ungovernable, or how to manage this at an enterprise scale. All right, so I promise this is the last time I'm going to mention Hudson. I see someone in the back kind of twitch every time I say something. But it was really, really cool because you could click buttons and create a reusable, reproducible-ish nightly build. Absolutely, positively, amazingly cool. And then the next kind of like wave of CI, the Travis, the Circle, the GitLab, the Azure DevOps, are all fabulous and unique in their own ways. The fundamental thing here is your pipeline now has become code. So you can version control your pipeline, and that is absolutely really, really cool. But it's still a little bit of a problem for templating and efficiency because you have the same thing. Let's say check out a repo written by each team doing its own thing, or each company doing that. And it gets a little wasteful. It gets wasteful of compute time because you're checking things out, every time. But it also gets a little wasteful as far as now you have 100 little more bits of scripts to keep up to date. And there's got to be a better way. So what if our CI pipeline was a package ecosystem? So let's take all of the amazing time and effort savings of a package ecosystem and make CI awesome. So instead of writing all your own JavaScript, you can use NPM. Instead of writing all your own Python, you can use PyPA. Same general idea at a high level. So really cool idea because it can do all sorts of scripty things. And it also provides a place for vendors and integrators and all that good stuff to structure user interaction with their products. So, as a vendor, you would know where all of the dragons are in your product, how people want to use it and don't want to use it. And you can say, hey, we're going to deploy to place. We're going to scan code with settings with tool. We're going to build code, deploy code, all that good stuff. And it can provide a paved path for internal things too. So you can use GitHub Actions to template internally. We use it internally ourselves. See, kind of not sort of secret. GitHub Actions runs most of GitHub. We don't like to do things manually. And you can get those reusable module workflows from the open source marketplace, which is where we're going to kind of focus most of that time. Your internal organization, or you can define them yourself in your own repo. And again, you can run on your managed compute or bring your own. So this yellow box is where we're going to spend most of our time, but we can kind of flex into these others as needed. All right, so what's a GitHub action? There's one big file that kind of tells you what a GitHub action is, and it's in a repo, either the repo of the package that you're using, or if you're defining it yourself, it'll be in your own repo. It's called action.yaml. And it defines inputs, outputs, and then what's doing the thing. And under the hood, ideally completely invisible to your users, it's one of three things. It's some JavaScript, it's a Docker container, or it's a mix. So composite being mixes of all the things, inline, in repo, remote scripts, call other actions. Composites are kind of their own fun little thing. All three of these are great, and for whatever it is you're trying to do, you usually have two good options, and one that's kind of like, you could probably do it. But it's really, they all have their own use cases and tons of space for user preference. So let's talk about JavaScript. Full disclosure, I'm still a little bit scared of JavaScript. I am the most back-end person to ever back-end. I will do Go, I will do Python, I will dive deep into all sorts of other things, love shell scripting. JavaScript scares me. So a couple caveats about this. Pure JavaScript only. Node 16. We used to say Node 16 and Node 12. Node 12 is deprecated or being deprecated imminently. And it's been nagging at you for a good couple of months now to say, hey, you're using Node 12, please stop this. So let's talk a little bit about what really happens when a job is run. So the compute is going to download the GitHub action. So it's going to check out the repo at the SHA or tag that you tell it to. You can also do a branch, but please don't do that unless it's something that you're developing yourself. It's going to run with a bundled version of Node.js. So the runner agent has a bundled version of Node. And then all of the dependencies have to be in that repo. And let's talk a little bit and dive right into the deep end of dependency resolution. We'll do script injection like right at the end. That deep pit of dependency resolution in JavaScript, at least in GitHub Actions, is really pretty shallow because for portability, all of your dependencies in a JavaScript GitHub action are vendored. So that means you have to check in your package JSON, package lock, all of your node modules, all of that gets checked in. Another kind of side note here is that it means you can't really hide dependencies or require anything on a self-hosted environment. So you can't require and call like any additional binaries or anything like that. It's like pure, you do the JavaScript. And the other kind of nice thing about that is like a software composition analysis tool can see all the things. So you're checking in your manifest. And your static analysis tools can also see all the things. So you're not hiding code from anything, like it is a reusable box. I like to talk about containers. I talk about containers a lot. Specifically though, with GitHub Actions, we assume that you are using Docker, not Podman, not any of the other Ravensburger puzzle that is the CNCF landscape. And really the big thing here is that sometimes a container action can have multiple containers, and we're going to assume that those containers can talk to each other. Or your developer will be assuming that, you know, if this action needs to have 3 containers and all 3 need to talk, like that'll be an assumption. I do see some people try to use like Podman Docker and some of the other aliasing packages, and sometimes it works, sometimes it doesn't. Just at the end of the day, we kind of assume Docker. And you can do one of 2 things with containers. You can build and run a container. So your action YAML would have a Docker file checked into that repo as well. And on each and every run, that container is built from that Docker file. Or you can say, hey, we're going to just run this container. You need to be able to pull it. And these are the inputs and these are the outputs. And you can get the beautiful thing about containers, which is you can write in any language you'd like. You can do all the fun things. And it's really just an abstraction above the provided compute, which is the whole promise of containers. However, image provenance, container hygiene, all that good stuff is on you. So let's talk about downloading from a sketchy URL. It's normally not this obvious. It's normally like a typo squatting image on Docker Hub or something like that. But please, please, please read your Docker files. I'm going to highlight this little bit right here, curl tac K, specifically the tac K part here, which disables TLS verification. I see this way, way, way more than I ever want to see this. I never want to understand that curl tac K is disabling TLS because it is 2023. We are civilized human beings and we do not disable TLS encryption. However, that's not the world we live in. And we're going to pipe it straight to bash. Yes, we're going to YOLO that. And then lastly, we're going to run it as root. So those are like my top 3 things that I look at when I look at container files. But the TLDR here is that your basic container hygiene is still important. And then a little bit about the container execution environment. Your compute design for containers becomes way, way more important here. Because in general, where we are with the self-hosted, like GitHub, you're using GitHub's hosted compute, is if you escape from a container, you're escaping into an ephemeral VM without a ton of extra goodies. So it's not really a big deal. However, I have absolutely walked into this bottom situation where somebody's using a really old version of Docker and they're running all their containers as root, and it's a shared persistent environment. And what I mean by that is we're providing compute, say, at a company-wide level, and projects A, B, C, and D are all sharing that compute. But everyone knows that there's that one project that's kind of full of people who don't care. Or people who just copy paste things from Stack Overflow and not really read into what it is. And when you have a persistent environment, that means a compromise can be persistent. And the runner agent does a lot to prevent this. So I'm going to go ahead and do my first tiny little break and show. And then, whoa, way over here. So here's when you actually build and run a container image. So what actually gets run is this big Docker run statement. So up here on line 2, we did the thing where we built the Docker image. So here's a Docker file. So we're saying, hey, we're going to build this Docker file. Everything here is contained in this repo. And we'll dive a little bit more into it here as well. So here's the name, here's the label, here's a working directory. And then we're going to throw in a bunch of environment variables in. We're going to bind mount a whole bunch of directories, but we're not going to just Docker run -- privileged. Notice -- privileged is not here. All right, so let me move my mouse back over here and play from current slide. And then lastly, I want to talk a little bit about composites because this is kind of like a weird catch-all. And it's what you really think about when you think about what your legacy CI stuff is as well. So a composite is an action that is tons and tons of various parts and pieces. So you can chain actions together. So you can call one action that can then call 3 or 4 other things. So say you can have a JavaScript action leading to an inline script, leading to a container, all as a single reusable template. And you can also run scripts inline or in the repository, and you can say, hey, we checked out this file, run this file. So lots and lots of slides here. Let's actually get to go into stuff. All righty. I'm going to move my mouse all the way over here and try to look at the thing I can't. So the first thing I wanted to kind of walk through here is actions checkout. I spend a little bit of time talking about how much I love this action end to end because I supported a bunch of different projects and each of them had their own thing that they wanted to do with the simplest task, which is, hey, check out this repo or check out these 3 repos or check out all the submodules for this repo too. Yes, pull LFS, don't pull LFS. So this is a JavaScript action, and let's go down here. Here's that action.yaml file. And it's a pretty simple YAML file. So we're going to give it a name. We're going to give it a description. Because we like you, we're going to make that description actually somewhat accurate. Here's our inputs with input descriptions. And all the outputs as well. And we can say, hey, it runs using node 16 with this index.js here. So can everyone see this screen? I know this is kind of a bigger room. Good, awesome, thank you, especially you in the back because you guys are way far away from this. All right. So let's scroll down a tiny bit because here's what this looks like as far as usage. So rather than having 30 different teams with 30 different scripts that say, hey, run git clone blah, cd here, run git clone blah with all of the arcane git command line arguments that you need. It's YAML. Yeah, it's just YAML. And the fact that it's just YAML is really, really nice because it means that I don't have to think too hard about hey, what is that command to check out a specific ref? What is the command to set up SSH on Jenkins? I might have some trauma about setting up SSH keys on Jenkins. And all of these, all of the lovely different settings that you can have. And then of course we have a ton more documentation here as well. And then what this looks like at runtime is this. So let's go through a job kind of based on containers here real fast. So on the setup job step, we're actually going to print out a whole bunch of stuff to the console. So you can see this is using GitHub's hosted compute because I'm lazy and don't want to run a 3-hour build job on my desktop. So I can see the operating system, I can see the runner image, I can see tons and tons more stuff. I'm going to talk about this a little bit more, but GitHub has a built-in JIT token, and this is all the permissions that were given to that token when it was run. And then we're going to download all the required actions. So we're downloading actions checkout v3, and it's actually going to print. So v3 is the tag that I specified. Tags in Git are mutable, which means that you can tag something as v3, you can commit, change it, and then move that tag to be the newer commit. However, SHAs are not. So because I said I'm going to use a tag, it's still going to print that SHA out for me for what the code was that actually ran. And then here's running that actions checkout. So with the repo, it's not going to print the token because that would be a little too obvious. And it'll print some of the other kind of defaults here. So strict SSH, we're going to persist the credentials. We're going to do this as a clean checkout, fetch depth of 1. So we're only going to get the latest version. We're not going to get the whole history. And then it's also going to print the Git version info. So it'll print the version history for you as well in the logs. And the whole thing takes about 1 second. So easy peasy. And more importantly, the number of times that I have had to mess around with trying to remember Git credentials is nil. All right. So let's now go to, where's my cursor? There it is. Whoa. Let's talk about build it and run it. So behind the scenes, here's that GitHub action that was in that repo. So this is the thing that got run. So that action YAML file is a lot smaller because this GitHub action does a lot less using Docker file. So it is on you to look at that Docker file. All right, couple problems here with this Docker file. Deliberate on my part, but if you were trying to do this more ephemerally, where is it pulling this? Just yeah, as you're trying to review things, where are you pulling this Docker file from? In this case, because this is GitHub's hosted compute, it assumes Docker Hub. So it assumes a reasonably safe default. But yeah, just keep that in mind. There are no pinned dependencies here. So I just said update all, clean all. This is not an idempotent build in any way, shape, or form. And then we're going to run an entry point script. So very, very easy to automate. Little less easy to audit. However, here's that entry point script. And not much is going on here. So we're running a RPM build. However, that was on me to figure out, and this file actually needed to be looked at. And then here is the build step of that. So run it, build it, pass in a whole bunch of stuff, and then there's thousands of lines of output for building an RPM that I'm not going to go through in any great depth. And then the other option here is pulling and running a container. So when you use GitHub Actions to build your GitHub pages, So there's kind of two models for pages sites now. You can do the traditional build off a branch, or you can define a GitHub action. And when you use the GitHub action, it actually is just using a Docker file. And you would know that by looking at the action.yaml file. So you have inputs, you have runs using Docker file, and here we're telling you what Docker image and tag is getting used. So it is now on you to audit, as say a user requests this action to use of, hey, it says we're running this this publicly available Docker image. What's actually going into that image? For GitHub, we're doing everything kind of in the open, so it's a pretty straightforward task. But there are 19,000 items in the marketplace right now for GitHub Actions, and not all of them are quite as open and transparent. And we'll touch a little bit more on that in a bit. Oh, we just went through that page. And then here's using that in a pipeline. So all of that. So we're going to check out the repo. We're going to configure pages. We're going to build it, and we're going to upload the artifact. And then in practice, what this does is on setup job, it's going to download all the actions, and then it's going to pull the images. So it'll pull down the container image that you need to run. And then it'll do the thing where it actually builds it and does all the other stuff. And then lastly, composites. And composites are kind of where things get a little tricky because you can have so much stuff in here. But here's an example of a composite action. So you have some inputs here and runs using composite. So as steps, we're going to go away, code navigation. You're taking up valuable screen real estate at 200% zoom. We're going to check out the repo. We're going to run an inline bash script. And we're going to pretend we all know what all the sed magic is going on here. And then we're going to, at the very end, upload some of the files that shell script created. So it is on you, and where I would really spend a lot of time on when a user requested an action was to look at this action YAML file and copy paste this script into something to analyze it. Because normally what I would do is look at that and go, oh, actions checkout, yeah, whatever, okay. Oh, actions upload artifact, okay, whatever. Like that's not where I would spend a lot of time. But running an inline shell script, that does make me a little nervous sometimes. And here's what that looks like. Then I'm going to export autolog build. Click. Sorry, the Wi-Fi is a little sluggish for me. So on setup job, we're going to download the images that we need. So we're downloading the action. We're downloading the checkout. We're downloading upload artifact. So it will recurse those dependencies down. And then here's where we're actually going to run it. So we're going to run checkout. We're going to set up auth. We're going to do all the things. And then here's where we're actually going to upload that here. Oh, that was not part of this. Yeah, that's not part of this group. Okay, awesome. Back to PowerPoint for a tiny bit. Sorry, guys. I do have a little bit more on the slides. Because I really, really, really want to talk about script injection. I know it's everyone's favorite topic. Because every system that has stuff in, process going on, stuff out, needs to handle the stuff that's inbound safely. So as you're looking through a user requested or user written GitHub action, here's where I would like to think about the data flow. Like, are the inputs, could they be untrusted? Specifically, GitHub can trigger on lots of things like issue titles or bodies. You can pull in a lot of extra information. And do those get interpreted or executed directly, or are you saying, hey, variable is going to be equal to this thing, and then we're going to sanitize that variable? My other kind of makes the hair on the back of my neck stand up is like, what are we opening network calls of any sort? Are we downloading stuff? Are we uploading stuff? Reading, writing to the disk. And general guidelines on this is like, hey, we're going to set this policy of we're going to prefer to use a pre-written action when we can. So we're not going to write 30 different scripts to check out Git. We're going to use a pre-written thing. Scan with some static analysis tooling if you can. When you can't, store as an input as an intermediate variable, sanitize it if you can. And at the bottom is a whole security hardening guide for GitHub Actions. So if you want to spend another couple of hours on this, and I highly recommend it, do really dive deep into that link. And here is an example of a script injection. So in show. So down here, so here's a quick script where we're going to get a PR title. And then we're going to just say, we're just going to evaluate it with bash. So if the title is this, then we're going to do this thing. Otherwise, we'll do this thing. And on eval, so this line right here, we're going to look at that title, and then we're going to execute this. So if this attacker creates a pull request that's escaping out of that, and then running a shell command just to list the files there, like that just gets executed. And the good thing is here, with a pull request type workflow, is you can say, hey, we're not going to run GitHub Actions, and we won't by default on pull requests from a first-time contributor. So normally it's not your contributor that's 10th time, 100th time on a public open source repo that's going to do something silly, although you can require approvals on every pull request run. So at least in this case, this one's pretty straightforward to spot. Let's go back to PowerPoint real fast. Play from here. All right, no, really, play from current slide. Thank you. And I just wanted to put a little bit here on trigger warnings because GitHub Actions can trigger on lots of things that are not pushes. So not every CI system can do that. So if you open an issue, an action can run. If you change a wiki, an action can run. Deployment events, discussion events, release events, anything, a lot of things that aren't strictly pushing code can trigger automation. Reconsider running requests on a fork from a public repo. And then not so much of a compromise situation, but in my initial rollout of GitHub Actions at scale, I accidentally got the entire company's IP address blocked from Docker Hub. And that's a good 6-hour lockout. So try to think through concurrency. GitHub Actions supports matrices that'll end up in up to 256 parallel runs. So that's 16 by 16. And that's a great way to tie up all your runners, have very, very, very peaky loads, run way, way more jobs than needed. And if you're using GitHub's hosted compute, that's kind of our problem. But if you're hosting it yourself, this is very, very, very much your problem. But all is not lost. All of these problems that I've been talking about are true of all package ecosystems. It's not a GitHub Actions problem. It's really thinking about your CI more as NPM or Pipa or NuGet, et cetera. What I would like to really drive home is that Git tags in and of themselves are mutable. So pin to a SHA. So instead of saying @v3, you can do @SHA. And for lower trust environments, that's really, really important. We're going to talk about a company allow list more in a little bit, require review with code owners, and make it internal. If you want, conditions apply there. And basically everything in the marketplace for GitHub Actions is a public repo. In order to publish your action in the marketplace, it has to be a publicly accessible repository in GitHub. And there's tons and tons and tons of tools that are free for open source for security. highlighting kind of R3 there for Dependabot for software composition analysis, CodeQL for static analysis, and secret scanning. But there's also a lot of other controls that you can put in place here. I'm going to kind of keep moving a little bit because we're a little tight on time. So let's talk about secret scanning, or secrets. You know, this is secret information, so you should look at this, secrets. It's a problem everywhere. Not gonna lie, as a developer on my laptop, there is a text file full of personal access tokens and other such shenaniganry. And they all have expiration dates of like 3 days, but you know, like it's there. I copy paste, I'm developing something. But I can't commit it into GitHub. So we block a lot of our known secrets on public repos. You have lots and lots of options there on blocking secrets from getting in your repo. But really, we want to talk about it. You can store it on a persistent machine. You can deploy it in log credentials. And yeah, when I first got started in IT, I found JDBC URLs with passwords written in plain text in a world readable directory in production on user-facing systems. It happens. Everyone has a story on this, but let's go a little bit deeper. If there is nothing else you take from this talk, please remove all credentials from all your repos and CI processes and rotate them. GitHub has a built-in secret store. It is built on libsodium. So when I was calling a GitHub token, I can also store a credential from something else. And you can store and control this at the repo org or environment level. So it's a little bit of a different password management than a lot of your other CI systems. Big important caveat here is for binary secrets like your SSL certificates, et cetera, or X509 certs, or structured data like YAML, you need a base 64 to have a text string, and then you'll decode it on the other side. And I have an example of that in just a sec. But you can also bring your own. Just wanted to highlight the top 4 that I see all the time. So Azure, AWS, Google Cloud, and HashiCorp Vault. So they all have official actions. And you can use those instead of trying to write your own API calls here. That built-in just-in-time auth token is configurable. It has really, really granular permissions, and it only lives on 1 token. But let's make it really, really hard to do dumb things, because here's a questionable maneuver here. I'm echoing a secret, piping it to base 64 and writing it to disk. Not the best idea, honestly. There's a little bit of a better way to do this here. And here it is. In this case, I'm deploying to Azure. Azure has a pre-written action. I can define all my things, and there's a lot fewer things that can go wrong in that. But really, doing questionable things with credentials is a great place to look. First, second, last, but don't do that. And I'm going to talk a tiny bit about GitHub Actions infrastructure. So infrastructure is cool again. We have hosted compute. That's what I've been kind of showing this whole time. But you can also bring your own. Completely free for you to bring your own compute, but you, of course, are paying for your data center, AWS, Azure, whatever. But all the security and operations are on you. When you use our hosted compute, you're getting ephemeral VMs. Like full stop, you're getting a VM, it's brand new, it is clean. At the end of your run, pass, fail, whatever, it is murdered, heartlessly rewritten. And there's tons and tons of dependencies preloaded on there. So it weighs in at about 50 gigs. Lots and lots of stuff on there. There's the repo that defines all of them. And everything is kind of magic. It updates once a week or so, scales, caches. But I say magic, it's not. Running secure, available, and scalable compute is really, really hard, as I learned trying to do this. So here's a couple, a very short list of decisions to make when you're self-hosting that will affect this model. So what type of compute that you're running on, physical hardware, VMs or containers, ephemerality, your base operating system, what software are you going to include, who all can use it, please, whatever you do, log it, send your logs to a seam, update your stuff, all that good stuff. And really think through the blast radius of a compromised runners. So ephemerality helps a lot because persistent compromise just is a lot more difficult. And VMs in physical compute can isolate themselves better than containers because containers are fundamentally just a Linux process with some special guardrails in the kernel. And then it's a little bit harder within a self-hosted runner, mostly because when you're self-hosting, you're doing this because you have a trusted boundary, and that runner is inside that trusted boundary. And then I am like 4 minutes left, so I really wanted to talk about this. So Charles de Gaulle famously said about France, how can you govern a country which has 246 varieties of cheese? And I tried this at the enterprise scale. How do you govern a company with 19,000 pipeline steps available? And that's currently roughly what's in the marketplace right now. And the first thing you do is at the enterprise organization repo level, you can allow policies here. So I don't do this for my personal projects because they're personal projects, but what I do and don't use at work is definitely controlled in some ways. But really, the biggest thing that I wanted to drive here is that maturity doesn't have to be slow. Normally when you say, hey, you need to open a ticket to request something, you're like, yeah, whatever, I'll get it done in the next 3 months. But a maturity model really can shine here because you don't have to allow marketplace actions at all. You can have allow list. It's not a everything or nothing situation, but defining that middle is where your threat model is fundamentally going to really shine. And what I mean by this is here's a reasonable process to do this. So a user wants to say, hey, we have a GitHub action. They're going to open a ticket. And then in this case, there are 3 approvals. So legal might want to take a look at say, hey, no, really copy left aggressive licensing, no do no evil licensing, whatever legal wants to do. We're in a law school building. I genuinely do not know what those people do, but I know it is fantastically important. AppSec, InfoSec, is this safe? Or do we need to fork it and scan it? Do we need to run some sort of code review? What are you going to look for? Please do look at the ingredients. And then on the infrastructure side, can we run this? If you are asking for a container action, you need a runner with a container engine available on it to run a container. But really what's super critical here is having that SLA of less than a week. Because this is how you prevent people from forking a thing, bringing it internal, but it's still doing something unsafe. So really what we want to do is understand at every point in the pipeline, how the system can be circumvented by people and designing people processes that work here. Because here are some really great traps to watch out for. You brought it internal, then you never updated it. Corporate proxies and TLS encryption, I will die on this hill every single time. Every time you install a break and inspect certificate, if anyone notices it, the first thing that's going to happen is someone's going to Google, hey, I'm getting an SSL error, and the top answer on Stack Overflow is disable SSL verification. Every single time. But disabling SSL verification does just work. Maintenance of your systems, internal and external. It's just maintenance isn't sexy. Maintenance doesn't get anyone promoted. Maintenance, it is what it is. And then really what this picture is all about alarm and ticket fatigue. Managing user requests can kind of suck sometimes. Scanning CI infrastructure is really noisy, especially when you have 10 different projects trying to share the same compute that all need 10 different things. I'm thrilled developer experience is getting so much time and attention, but if every company is a software company, talent is expensive, and that really should extend to our operations and our security folks. Having 10,000 alerts sucks, and having 10,000 alerts on VMs or requests in queue sucks. So let's also do developer experience, but also maybe our security and InfoSec experience as well. And here are some resources to learn more. Specifically, I wanted to call out GitHub community, which is how we gather feedback from the community. We do have a public roadmap, so definitely want to call that out. We have all of the security guides go, if you want to spend hours and hours and hours more, there's where we can. And then lastly, we have a bug bounty program. So if you have found a thing, please visit that link. Alrighty. Thanks.
We have time for maybe one or two questions.
Of course. Yeah, totally. We have time for all the questions. Well, maybe not because we do have another speaker, but yeah.
So does GitHub have, or can anybody point us to any sort of tooling that has, or that'll look at your actions, look at your pipeline in your repo and say, hey, you're doing stupid things here, here, and here?
Yes, through professional services. So we do have a professional services arm, so like a consultancy type thing. And they can help you develop best practices and all that good stuff, specific to your business.
So you mentioned that the authentication token, that JIT token, is configurable with what it can do. Is there an interplay between like the user that triggered the actions and their permissions and how that configurable? Like how does that auth kind of work?
Okay. So this gets a little sticky. So let's say I, Natalie, have write access to a repo and I'm opening a pull request. The fact that that pull request was opened by Natalie is handled by GitHub, like not actions. The actual JIT token is only scoped to the thing that's defined in the workflow. So by default, I believe it's read only, or read and write. I'm not sure, but there's actually like 20 different, individual scopes. So you can say, hey, we can read to this, but we can write to security events. And really what I strongly suggest is at the org or enterprise level that you set that to read by default only. And then in your pipeline, have a discussion about saying, hey, we need the ability to write to security events. So we need to ask for this token for this workflow. And because your workflow is code, that discussion can happen on a pull request. Or at least it can be gated. So that's where we were kind of like out of scope a little bit on that left-hand box of like your GitHub settings versus like the actions compute.
Cool. Okay. Let's thank Natalie again.
Yeah, absolutely. Oh, thank you.
I know I mentioned the walking mic, but I